All right, so far we've reviewed how to, if we have the graph, to write the equation of the lines. And then once we have the equations, how to set them equal to each other to find the point of intersection. Here, for our lines that we have today, we know that the point of intersection is 4, 2. We've tested that a few ways and we have confirmed it. The last thing that we are going to look at, though, is a method of solving systems of equations. So it sounds like a big fancy name, but it just means if we have two or more equations with the same variables. So here we've got two equations and we've got two variables, x and y. That makes this a system of equations. And this method that we're going to learn is very useful for lines where we have the equations not in slope-intercept form, but what is known as standard form. So what we're going to do is we're going to rewrite our two lines in standard form, and then we're going to use those lines in standard form to show how to do what's known as the combination and elimination method for solving a system of linear equations. So again, that all sounds extremely fancy and maybe complicated, but all we're doing again is learning a technique to find the place where the two lines intersect. So first, let's go ahead and rewrite our equations in standard form. Right now we've got -1/2, let's start with what we got here. We've got y equals -1/2x plus 4. And we can see that what we're going to need to move to put this in standard form is the x term. So we're going to add 1/2x to both sides, and we end up with 1/2x plus y is equal to 4. So now our blue line equation is in standard form. We're going to do the same with our green line, and here this one is so simple. We can see that all we're going to have to do is subtract x from both sides. So our green line is going to be -x plus y is equal to -2. So we now have our two lines, blue and green, in standard form. Now what we're going to show how to do is the combination and elimination method. And again, the point of this method is to find the place where the two lines intersect. We're doing all of this with lines where we know where they intersect so that we can show that the tools actually work. The way that these methods work is we want to line up either the x's or the y's so that when we combine them, they disappear. Right now we've got a half of an x and a -x. If I multiply everything in this line by 2, now I'm going to have a plus x. So I'm going to rewrite this down here. This is going to be x plus 2y equals 8. So I've just multiplied this term by 2, this term by 2, and this term by 2. Again, we did some of this in the last video, but as long as you maintain the balance in the equation, you have not destroyed the equality. The equality is maintained. The reason that I've done this is that now when I add these two equations together, -x plus x, the x's are going to disappear. Then we've got y plus 2y is 3y, and -2 plus 8 is 6. Now we have one equation and one variable, which means that we can solve it. And in this case, 3y equals 6. All we've got to do is divide by 3. And now we've got y is equal to 2. Now, am I happy or sad that I found y is equal to 2? Well, of course, I am elated. I am thrilled. I am overjoyed because we know the y-coordinate where these two lines intersect is y is equal to 2. Okay, we found y is equal to 2. How do we find x? Well, in this case, we can just plug the y back into one of the equations. Again, you know, I like using the most straightforward one, the one that doesn't have any fractions or anything like that. So I'm going to do negative x plus 2 is equal to negative 2. Subtract 2 from both sides. Negative x is equal to negative 4. I can multiply everything by negative 1, and we find that x is equal to 4. And again, I'm so happy to see x is equal to 4 because the point where these lines intersect is where x is equal to 4. So again, this is an example of what's known as the combination and elimination method. Sometimes it's known just as the combination method or just as the elimination method. But combination because we combine the lines, and elimination because we're combining the lines in such a fashion that we're making one of the variables disappear. Once one of the variables disappears, then we have a line in just one, or an equation in just one variable, and that means that we can solve it. So hopefully these are some useful tools, and we're going to continue talking about this in class tomorrow.